So let us look at this question. This was asked in 1992. Remember, in those days the options could be more than one. Answer need not be only one. Okay, let's see here. What's the question? Consider SLR1 and LALR1 tables for a given CFG. Which of the following is true? So when you look at SLR1, LALR1 for a given CFG, A is goto of both tables may be different. Shift entries are identical in both table. Reduce entries in table may be different. Error entries in table may be different. So if you look at SLR1 and LALR1 are in general all LR parsers. Where exactly the difference lies? What is the procedure? All 4 LR parsers basically differ only in reduce entries. Okay, that because of that reduce entries only it is 4 different types. So that means the shift entries in both tables identical is true. Reduce entries different is true. And what about error entries? Error entries are nothing but blank entries. So when there is a difference in reduce entries, naturally blank entries also will be different. Okay. So when there is a difference in one particular entry, naturally the blank entries also differ. So these 3 are correct, but go to is different is wrong. So I think the question should have been asked in the other way, which is false. Okay, which is false means only A, which is true means B, C, D. Got it? Now look at the next one. This was asked in 2003. Assume that the SLR1 parser for a given grammar has N1 states. SLR1 has N1 states, LALR1 has N2 states. Then what is the relation between SLR1 and LALR1? What is the answer? For a given grammar, when you construct SLR1 and LALR1, both will have same number of states. And consider a grammar. Okay, this is capital and this is small. S2CC, C2, CCRD, and check whether this grammar is. You remember this grammar is something similar to our first example, AA, A2, AARB. And what is that we have seen? This grammar can be parsed by all the 4 parsers. It is LL1, LR0, SLR1, LALR1 as well as CLR1. So if you look at here, or if you don't remember that also, simply by looking at the grammar, you can always check out LL1. This is LL1. And what about the other ones? Here it is like not LL1, so this is wrong. Okay. And here it says it is not SLR1, so this is wrong. Here it says no doubt to verify these 2 options. B you can easily verify just by not LL1, you can say you can rule out this. But to check out C and D, what you have to do, you should have a DFA. Okay. But anyway, here it is, since it is SLR1, not SLR1 is not right, but not LALR1 is also not right. Hence, the right choice is only LL1. So look at this question. Construct the go-to graph with LR0 items. That means with canonical collection of LR0, draw the DFA. Go-to graph is nothing but DFA. And find the number of SR and RR conflicts, or we can change it as find out the number of inadequate states in the go-to graph. Okay. So what we have to do? Draw the DFA. How do you draw? Start with augmented production. It is with LR0 items, so no need of look ahead here. So because of S, dot SS, dot A, dot epsilon. Do you have any SR or RR conflict here? Look at this final item together with non-final. So there is a SR conflict. Now look at on S. What you get is this, and S2, S dot S. Here is a match, here is a match. Now because of S, S2 dot SS dot A dot epsilon. So look at here. Let's take this as I0, this as I1. In the state I1, once again SR conflict. And here there is a final item. Is it a final item which specifying a reduce action? Do you have a RR conflict here? Remember, this is not for reduce action. So this is not, this and this is, no doubt it is a final item here, but this is not a final item that specifies a reduce action. This final item is specifying a acceptance. not for reduce. So this is not a reduce. Once again it is only SR conflict. Here you have SR, here you have SR. And on S what happens? S to SS dot, and here S to S dot S. Now because of S, dot SS dot A dot epsilon. Look at this state I3. What you get? Once again with these two, one SR, and here if you look at these two, we have an RR also. And what else you get? If you take on S once again it repeats the same state, and on A no doubt you get some simple thing. So this completes your DFA. Now tell me how many SR conflicts? How many SR conflicts and how many RR conflicts? RR conflict is only 1. SR conflicts are 1, 2, 3. Or I can modify the question like this. Find out the number of inadequate states. Means how many? 3. Number of inadequate states are 3, which are nothing but I0, I1 and I3. It can be asked like that also. So let's take this grammar. The question on this grammar is like this. Draw the DFA with LR1 items and find out the number of inadequate states. That is first question. And second question is find the type of inadequate states. Okay. So let us look at the first part. What is the first part? Draw the DFA and find out the number of inadequate states. Inadequate states is nothing but a state which may contain either a shift reduce conflict or reduce conflict. So for that you have to draw the DFA with LR1 items. How do you start? Start with augmented production with dollar as a look ahead. Now because of S, add the rules for S, AS, SA, dot A, where look ahead is given by first of dollar. Okay. Now because of S, here you may have to add once again dot AS, dot SA and dot A, where look ahead is what? Because of this S you have added, look ahead is first of A dollar, which is A. Actually you can have items like this, or instead since these LR0 items are same, look aheads are different, you can merge these two as a single one by adding the look ahead over here. Okay, this is how you can take out this. Okay, this is your I0. Now I0 on S, what do you get? S to S dot dollar. Here there is a match and here there is a match. So S to S dot A dollar and A. Okay, this is your I1. Now this one on A is what? S to A dot S dollar A. While finding the transition, copy the look ahead as it is. Here there is a match and here also there is a match. A dot. Look at this. State I2 has a conflict now. Why? Final item together with non-final item. Okay. A dot. Yes. So here because of yes, actually we need to add even closure. When you apply, this is the result of transition on A. Here there is a match. So A dot S, S dot A. Here there is a match, but evaluation is not complete without applying closure. Now if you apply closure on this, what you get? Because of S dot AS dot SA dot A, where look ahead here is, for this yes you have added look ahead is this. Okay. So look at the state I2. There is a final item as well as non-final item here. So because of which we can say there is a shift reduce conflict. There is a final item. Okay, this final item is matching with one of the, this look ahead has a this final item has a look ahead which is matching with non-final item. Since these two are matching in LR1 items, this is a SR conflict. Okay. Now, let us complete the DFA. On S, S2, AS dot. Here also S2, S dot A. This is I3. On S it is this one and this one. Now on A what happens? Here it matches, so it gives A dot S, which is nothing but the same state. Any more transitions? That's all from I2. Coming to I1, I1 on A is S2 SA dot $R A. Let this be I4. Okay. Now this one on A is S2 SA, which is nothing but I4. That completes our DFA with LR1 items. Now let us look at the inadequate states. No doubt whenever there is a final item you need to check out. Here there is no final item. So there is no possibility of any conflicts here. This is only for the acceptance. If you look at I2, in I2 there is a final item here and non-final items here. Okay, this is one non-final item and this is also one non-final item. Where, which non-final items we have to consider? Where there is a terminal next to dot. So if you take the combination of this S2A dot and S2 dot AS, here this one, this final item has a look ahead which is matching with this terminal, or if you take this also, this is matching with this. So because of this matching, okay, because of this look ahead matching with this terminal symbols in non-final items, we say there is an SR conflict. Okay, so the number of inadequate states are I2 is 1. Similarly, if you look at I3, in I3 there is a final item and final item has a look ahead which is matching with terminal in the non-final item. So this is also clearly an SR conflict. So the number of inadequate states are 2 and that states are nothing but I2 and I3. And what is the type of inadequate state? Here it is SR conflict, here also it is SR conflict. So answer for the second part is, it is type of inadequate state is SR, shift reduce conflict. So look at this question, this was asked in 2004. Which of the following rules violate operative grammar definition? So what is an operative grammar? A grammar which does not contain two adjacent non-terminals or epsilon production is always called operator grammar. So two adjacent non-terminals is not allowed. This is not allowed. So which violate means it's 1 and 3. These two rules. Whereas in between terminal, no two adjacent non-terminals means this is allowed. Now look at this question. You have a grammar here. Consider LR0 items. Some LR0 set of items are given 1, 2, 3. The question is, which two of them will appear in the same set of canonical collection of items? It's naturally LR0 items. When you consider canonical collection of LR0 items, which two of them will appear in the same set? Generally, which way you get the same set? Suppose look at here, when do you get this particular item? Transition on star, you will get this item, isn't it? When the next look ahead symbol that is seen is star, then naturally you will move the dot next to star. So this is a transition on star. Whereas if you look at here from the state, yes, transition on star would be only this one. You don't get any other. And if you look at here, when do you get this particular item? If the transition is on F, then move the dot next to F. Okay, so if you look at the transition on F, here you will get a dot and also here also you will get a dot. So you will get something like E to F dot plus C, E to F dot. But look at here, you have only this one. You don't have E to F dot. That means on transition F also you don't get any 2 here, only 1. And if you look at f plus dot e, when do you get this item f plus dot e? When the look ahead is, sorry, if you perform go to of the state on input symbol plus. On seeing input symbol plus only, the dot if it was there earlier here, it may be moved here. Okay. So if you consider the transition on plus also, only it matches only with this. That means this may be by applying the go to function on plus in any state. This is applying the go to function on f. This may be on go to function on three different conditions. That means none of them will actually be there at any point of time. All are independent, which may not occur together in any state. That's why D is right. And another question, simplest, which is that which of the following is a top down parser? Recursive descent, operator precedence, LRK and LA LRK. Which one? We know all these are nothing but bottom up parsers. So the only top down parser is recursive descent. And look at this, S equal to ICT SS1 or A, S to ES. What is this grammar? It's nothing but conditional grammar. If expression, then statement, else statement. Okay. So if you look at this grammar, what the question is, it is not LL1. It's given like it is not LL1 because it is left recursive. Is this grammar is left recursive? Do you find any matching here? What is left recursive? Whenever you have grammar of the form A to A alpha, if these two are matching, it is left recursive. Nowhere there is a left recursion. It's right recursive. Is it right recursive? Look at here. This is S1 and here it is S1. These two are also not matching. It is not even right recursive, but not a CFG. What do you mean by CFG? A context free grammar is nothing but left hand side you have a single non-terminal, right hand side you can have set of grammar symbols. So this is a CFG. So the only option left is ambiguous. No doubt this is the Dangeling else problem where it is left factored but still it is an ambiguous grammar. Remember in a CFG when you left factor a grammar, an ambiguous grammar, if it is left factored, it may not eliminate the ambiguity. Ambiguity still may be there. Elimination of left recursion is to avoid parser going into infinite loop. Left factoring is only to avoid backtracking, but nothing to do with ambiguity part. So this was asked in 2012 paper. The question is find the first and follow sets of A and B. Let's write first and follow sets. What is first of A? First of A is first of S. First of S is what? A here, B here as well as epsilon. A, B, epsilon. And what about B? First of B is first of S. First of S is A, B, epsilon. Now coming to follow. What is follow of A? Follow of A here is B. Follow of A here is A. So it is B comma A. What about follow of B? Follow of B is follow of S. Follow of B is follow of S. And what is follow of S? Follow of S is follow of A. So because S is start symbol, add $. So follow of S is follow of A. That means follow of A is, what is follow of A? B comma. In addition to that, $ also will be. So look at this question. This was asked in 2013. What is the maximum number of reductions that can be taken by a bottom-up parser for a grammar with no null productions and unit productions? Unit productions means it may be something like E to T, T to F, something like that. Okay. To parse a string with n tokens. So when you have a string with n tokens, the number of reductions, if you assume that at every step only one like that handle is reduced, only one symbol is reduced at every step. Finally, to reduce that to start symbol, the number of reductions would be n minus 1.